Well, let us continue.
So up to now, we have the formula, and maybe you need to check all the details to know the reason why. Okay, the reason why behind the formula. But at least I let you know we need to we can apply the formula to have the derivation. So look at these. Previously, we have this example. And this example doesn't have the results already. But right now, we follow the original one to let you know we have the 2, right? And the 2, it is okay to have the 2, but to have the 2, how to have this one by using formula? Okay, this one, it says, agree with the original derivation, right? But I just want to let you know the formula. And don't forget to have the absolute value. If we have these, I do not follow the way here. I just let you know my way. You see, we have 1 and 2, and also 1 and 2. So you see, what that means. Finally, in terms of y. Okay, so we have all these one, right? For 1 and for 2. And here you have a summation. So it says, first one, in terms of x, multiply the first one. And they are the same, this one. So that's why I simply put them together, but have the same scalar. Here, not scalar, but the same factor. If we have this one, then I think you can really easy to have the result. If you have the formula here, it's really easy to have the result. But I want to mention I use this one. I do not use this one because this formula will be easy to be memorized, right? If this one easier, so no need to use the reciprocal, you see? No, right? I use the multiplication directly. So I use dx sub I over dy. That says differentiation of x sub I with respect to y. Therefore, you will have this really easily, right? All right, so this is a way to have the result. Is it okay? If it is okay, and then this formula is okay because this one can be checked by the previous procedure. CDF first and then PDF. Here, no need to have a CDF first, then PDF. This one directly have the formula for PDF, and that's it. All right, so I think you can try the second example, this one. I think that you guys have maybe 2 minutes first to check. And can you understand this? And then I go through this quickly. As for the remaining cases, I think we won't check it, but you need to check it later. All right, then you have 2 minutes to check this example? Can you have the results? Take a look. All right, so please take a look for 2 minutes. Okay, so maybe not to 2 minutes, but right now I try to collect possible possible problem from you guys. So any question to let me know? Here I try to nominate and so that collect the possible questions or problems. First of all, Chunhao, any question? You can let me know through message or you can let me know by speaking directly. Any question from Chunhao? So any question? Okay. And Jinting, any question? Okay, good. And Diego, any question from you? And Andrew, any question from you? Okay, so of course you guys can check it. And Andrew, how about your comment? All right, so maybe some of you feels okay, and some of you still need to have more time to check it. But let me re-emphasize what we apply. In fact, we apply the formula. Let me have the formula again. But don't forget to have the absolute value. All right, so up to now we have these. Why we have these? First of all, absolute value, because positive, negative, to ensure all the values are positive, because we can see the probability. Probabilities are positive value, right? So that's why we have the absolute value sign. For the remaining, in fact, we just follow this concept. One y, okay, but we have 1x, 2x, and 3x. So we need to collect the probability using the 3x values. So that's why we need to have a summation using x. And using x, actually this one should be dxi. Okay, but using y, this is dy. Rewrite, then you will have my formula easily. However, if you want to follow the discussion here, that's okay as well. You see, this one, through approximation, we have a delta, but if no approximation, it should be d. Or maybe you can have the approximation using delta y. By using delta y, you will have the ratio. The ratio, then you will have the definition for differentiation. And likewise, you have the 3 probability. And all the 3 probability can use the formula. All right, but ensure positive, right? If ensure positive, then you can have the formula absolute value, and absolute value. All right, and rewrite. You will have my formula, and I like this one. Okay, but I don't like this. Well, maybe you have question. I don't like it, so I don't want to use it. Yeah, if you like it, you can follow the way, but I just follow my way. This way, follow the concept here. All right, so you will have a dxi over dy, and with the absolute value. And that's it. So I apply this formula. You understand me? If it is okay for application of this formula, right now, sometimes you have multiple I, but sometimes you have a single I. For example, this one, only single one. What is x here? It is 1 over y. If we have 1, you can have this. I use absolute value, so you will have this one. And this one equal to this. If you have this, and then it's really simple. Follow a formula, no need to have summation because single one. And here in terms of x, so you will have this one and multiply the absolute value. It is 1 over y squared, right? So you will have the results easily. You understand me? So we follow the formula, but we need to have some derivation. Once you have the derivation, you will have the result. And my results the same as this equation, right? Okay, that's it. As for the other discussion, I think you can check the slides here. By relate Cauchy random variable to Cauchy random variable, you see? Says Cauchy and Cauchy, right? And as for the other example, I think I will skip it, but therefore you to practice more. All right, so up to now, we have the procedure. The write CDF first, then PDF, or the formula for continuous random variable. And how about the results if we have the discrete type or discrete random variable? Here, I just let you know case by case. And that's it. So case by case, we can look at these. This one follow Poisson. And how about these? Well, look at this. It says you have the transformation PMF directly. All right, and once you have this one, for this case, then we will have X. All right, but in fact, we don't like this one. We will have a given Y. And once you have a Y, and then you will have the result. This one, square root. Why square root only? Because this one positive. And this non-negative. All right, so if a non-negative, so of course we only have the mapping. Positive 1, minus 1, no minus 1. So that's why we have the results here. All right. So it says, even we have Y. But impossible. So we need to remove the negative 1. So normally we should have summation of the 2, but impossible for 1. Therefore, we only have 1 to express this. All right, so this is the case for this example. Is it okay? All right, so this is a discrete type random variable. And these are the results of supplement 1. And actually, I go through this supplement quickly. This is supplement 1. And supplement 1 provide you the approaches CDF first and PDF or formula for continuous random variable. As for the discrete random variable, I let you know case by case. All right, so I go through the content quickly. This is an example to apply procedure, CDF first, then PDF. And here we have the formula. So that you know why we have the formula. Wait a moment. Any question? Let me check any possible message. So any question, if you have, you just let me know. All right, according to the previous messages, let me make sure again. For Chen Hao, right now, is it okay for you? You can let me know through message or say it directly. And likewise, any question from Diego? So Chen Hao, okay for you, right? Let's say you let me know maybe yes, am I right? And let me check the response from Diego. And also maybe Junting. So let's wait for a moment because I want to make sure you guys understand me. And in the past, I think maybe I don't have enough time, so I go through quickly. But I still think for the current discussion, perhaps I still need to let you guys have time to let me know your feedback. Okay, thank you, Junting. Sure. Diego, so let me continue. Here we have the results. I think formula and practice the formula. And finally go through all of the cases for contains random variable. And then we'll reach the discrete random variable. But discrete random variable, direct derive PMF. No need to have a CDF. But sometimes maybe we need to have a CDF first. But I don't think that is the usual case. All right, so that's why I let you know this one apply case by case for PMF directly. All right, that's all. This is supplement 1. I think maybe some of you feels okay, or maybe some still need to have more time, maybe by reviewing the video clips after classes. I think okay for that too, but we will have the next supplement. So let me continue. Of course, for all the supplements, you may check all the examples, or maybe you just try some of the selected examples. It's up to you. If you feel okay for you, then you just select some of the example. If you want to know, oh, and so that you want to understand, oh, that's okay for sure. But for me, I select some of the example and ask you guys to check the remaining examples. All right. It doesn't mean, yes, you need to go through all, but you probably think how many examples you want to go through. And if you think enough for you, then you just follow your way to look at the content of the example of the supplement. And next one, we talk about the transformation from 2 to 1. Okay, so here, something like you may have a decision based on Z. Well, Z is a function of X and Y. And likewise, you want to know the answer. Given the joint PDF, is it okay to obtain a PDF of Z? This is a goal of the supplement. For example, we may have the summation of X and Y to know Z. And here it says you may have the other functions, right? Before we start, I ask you guys if we have a question like this, what we might to do if we want to have the derivation. Previously, we have the CDF first and then PDF. Is it valid for this case? The answer is yes. Okay. And the second one we want to ask, is it okay to have the formula? The answer is probably yes. But we need to derive case by case, then we will have the formula. We don't have the general formula. Okay, so let us go to check. Right now we have x and y. And x and y with a function. Then we may have the specific area associated with a z. If we know exactly the area, and then we know how to have the region, to have the way to determine z, in particular probability of a z. All right, so region. All right, so this is an important concept, region. Why we have a region in terms of z, you see? If we have a z here, and CDF first, right? Again, CDF first. But for this region, you will have this for this region. For this region, then where we have the region, if we follow the current description, the region here, right? If we have the region here, how to have the results? The integral, right? So you may have y for the outer side and x for the inner side. Okay, for x inner side, x from negative infinity to the current point, the point here, z minus y. But for y, you can have the entire axis, right? Therefore, this is a region. If I will find the region, then we will know the interval for y and x. And the integral for y and x, you may rearrange it. How about y first and then x? That's okay. If you want to have a y first, then the same. But we have a z minus x for y. Okay. However, for x, we have a z minus x. The same. You may have the second equation. Either one is okay. All right, so up now, this one, you can express this in terms of a joint distribution for CDF of z. Once we have a CDF, know the expression for CDF, and of course, we want to know PDF. And then what to do? Of course, we apply differentiation. Right? Well, differentiation, we may have a lot of discussion so that we reach the results. And this is a formula. But this is a formula for this one only. Well, for this supplement, then we will have the case-by-case formula. And that's it. For the case-by-case formula, how to reach this? We apply the procedure. Then we will have the case-by-case formula. And that's all. Well, you can follow the current discussion by the concept of Leibniz. If you don't like it right now, I already have the results as well. I mean, the results as well. How to do? This one. Differentiation with respect to z. Right? So you may have these. Right? And how about these? In fact, you can use chain rule, right? You can perform differentiation with respect to this one, but later you need to perform this one with respect to the original one, z. If we have the differentiation with respect to z minus y, and then through the theorem of calculus, right? What is the result? You just replace, substitute the variable into the corresponding variable. Which variable? X, right? So you will have this remove integral, but substitute the variable. So finally we have this z minus y and y, but still have this. But don't forget dz minus y dz. However, this one equal to 1. So that's why we have this one directly. But we have the integral with respect to y. Look at these the same. And in fact, I don't want to use the concept of Leibniz. That's all. Okay, let me get back to this. Can you understand me? Perform differentiation with respect to z. So we do it. That's it. We do it. If you can do it, so consider how to get the result by applying the chain rule. If you know how to apply the chain rule and also applying the concept of theorem of calculus, I think you can obtain the results. Am I right? Okay, so that's it for this case. Is it okay? And let me check this one again. Chunhao, is it okay for you? And likewise, Diego, is it okay for you? All right, I think I just checked the two, and maybe you guys will feel never nominate anymore. Okay, later I may nominate the other guys. All right, so that's it. So if you understand that one, how about these? Currently, we apply the procedure, CDF first and then PDF. And once you have the PDF, then you have the formula. But this is the case-by-case formula, and that's all. And this is the first way. If we have the integration with integration with the inner side of X first. And this one with the inner side of Y first. So finally, we'll have outer side X. And for the two formula, the same. We can reach the same results, but looks like different. Slightly different, but okay at all. And in the following, it's just an extension. How about independent? Independent, then you have this. Independent, then you will have this. Right? Once you have this, we have a special definition, convolution. I just try to mention. Here we have a special expression. The special expression is called the standard convolution. All right. So this one, you just want to mention. If we have a special case when X and Y are independent, then sum of two random variables will result in the calculation in terms of convolution. So convolution this one or convolution this. Or maybe in the past, you don't know convolution. You can treat the current one to serve as the definition for you, or the first time to show you the standard convolution. All right, and that's it. So you just want to mention the convolution. So up to now, that's all. And this one, this is the first example. Talking about x and y are exponential and independent exponential random variable. And we want to consider z equal to sum of two exponential. And follow the previous example using convolution. So we may have this. And finally, we have the results here. All right, so exponential plus exponential. What is the result? This one. Exponential again? No, not exponential. But later we will already know this one is called the gamma or Erlang. Or you can check chapter 6. All right. So you just follow the formula to have the result. So I think you guys can check it. But for this one, example 8.3, you just follow the definition of convolution. But I just want to let you know, perhaps you have the tedious procedure to have the results, PDF. All right. And at this moment, I think that to you guys to check this. All right. I don't have enough time, so even we may have the tedious procedure, but I strongly ask you to review this example. Is it okay? So let me emphasize again, I strongly emphasize this example. So to review this example. Even it is tedious, but you need to check this one. So be patient to check this procedure. And in fact, another one, right? But for another one, I just want to ask you guys to think about this. Uniform plus uniform results in triangular. All right, so this one that you have the spatial results, uniform plus uniform, results in triangular distribution. Or uniform random variable plus uniform random variable results in triangular random variable. And that's it. All right, so this is a conclusion. Because later if we want to have some connection, this is a conclusion. And the conclusion that you have some possible connection. And the connection says uniform random variable plus uniform random variable results in triangular random variable, and that's it. I think this example is extremely important. So you need to go through and to understand how to have the result, how to have the conclusion here. Finally, you will have a triangular distribution. You see, triangular. And in fact, the current example, we have two solutions. I mean, maybe not two solution, two possible types of a solution, but the same answer. All right, so I think you guys need to check in detail for the two different approaches to have the same solution. All right, so about this, I think you need to check. So allow you to check after classes. But for me, I mentioned it is extremely important. So you need to go through again and make sure you understand these. All right, so I think at this moment, I do not nominate anyone to make sure the status for understanding this one, because right now perhaps you still don't know. So I just that you have the self exercise. Okay, so that is the case for sum, and another case for ratio. For ratio, I think you just follow the description to have the specific formula. I think likewise, you can follow the previous way, CDF first, and then you can have the special formula. And for the special formula, I think I skip the possible examples. And possibly you may have these. The same for me, I skip it. And the square root of that. And the same, I skip it. But you all know we may have the specific distribution. Here we have a radius. So you may take a look why we have the radius. And this is the summary. Okay, so Gaussian actually is normal. And the radius and the uniform. All right, so this is a conclusion, but I do not check in detail. I just mentioned we may have some specific conclusion. And finally, maybe we have the older statistic. Okay, older statistic. So this is an example talking about older statistic. Okay, so for the older statistic, the same, extremely important. That says you guys need to check it. But I skip the description. And then it is operation. All right. That's all. So this is the current discussion by mapping X, Y to Z. And maybe I skip some of the details because I think you guys will understand it takes time and takes a quite long time. So I cannot go through all the details, but I think it's still okay for you to go through those after classes. Well, that's it. So up to now, is it okay for you? Or maybe someone have the question want to ask me? Anyone want to ask me the question? If not, I think uh, that is the second break. Okay, maybe Jiting have some question. Go ahead. Jiting asked me the first question. the final report. Sorry, the final report, final exam, and the presentation, and the final report. Yeah, currently I have a concern. Can we catch up the schedule? I think maybe not exactly. Perhaps we may have a 1 week delay, or at most 2 weeks delay. Up to now, I'm not so sure. Is it okay to catch up the original schedule? All right. So this one, I doubt. Maybe not follow the original schedule. So this one, perhaps the tentative answer to question 1 of Junting. As for the second question, I think Junting want to know right now, perhaps you guys want to prepare the final report. As for the final report, up to now, we don't that we have the whole discussion, but at this moment, you guys will understand we need to have the random phenomenon. So you need to choose one paper with some random phenomenon, and you need to run simulation for that paper. So the scope of the paper, no restriction as mentioned by our requirement of the preparation to the final report. Okay, and of course, finally, if you finish all and you want to have the submission, similar to our programming assignment, you need to let me have the final report along with the paper. And also let me have the results within that report. And that's it. And if you don't have any confidence and want to ask me to check, you can let me have the paper first. I can check that one for you for sure. No problem. Okay, so I think the 2 questions using the tentative solution, they will be okay for you, right, Junting? I think I've seen 2 okays already, so it should be okay, right? And any other question? Maybe someone want to let me know the other question. You just go ahead. Maybe we can wait the response from Junting, but I try to also to check any other question. Oh, Chunghao, you want to ask me a question? Yes or no? Okay, thank you. Maybe the mode is not mute, so making sound so that I feel you want to ask me the question. Junting let me know, according to our preparation to the final report, we need to have the oral presentation. And oral presentation, at least you need to have the slides. And the slides doesn't mean the final report, right? So that's why I think you have the separate actions and separate activities, oral presentation before the final report. These are 2 activities. And that's it for Junting. Is it okay? Maybe that as well for the message from Junting. I think it's okay, Junting. Later I will check your message and answer to you. 5 minutes later. Okay, so I think maybe right now, let us take a break here. And 5 minutes later, we can restart. And I will answer or check the reply from Junting later. Okay, that's it. Take a rest again.